This is Engineering Marvels. In engineering, as in everything else, it's important to use the right tool for the job. Whether it's building a skyscraper or setting a packer down an oil well, one of the most versatile tools at the engineer's disposal is steel. Steel is an alloy, meaning that it is formed by combining multiple elements to create one new material. The primary components of steel are iron and carbon. Other possible components include familiar materials like nickel and aluminum, and less familiar ones like vanadium and molybdenum. Steel's versatility comes from the variety of combinations that can be used in its creation. Steel should be mostly iron, with not more than 8% of its content from alloying elements and no more than 2% from carbon. How the elements are mixed is also important. The properties of the steel will vary based on how the alloy is cooled and whether any additional heating or machining is done after the initial cooling. When selecting a steel to specify in a design, an engineer must consider the age-old question of strength versus ductility. Ductility is a solid material's ability to stretch under tension. The stronger the steel, the higher the stress that can be reached before yield or fracture. By contrast, more ductile steel will have the flexibility to bend before breaking. Structural engineers use steels with lower strength and greater ductility. Since load carrying capacity depends in part on the size of a component, and since bridges and buildings tend to have large components, it's better to have a ductile steel that won't fracture during a sudden load event like a hurricane or an earthquake. Mechanical engineers tend to use more brittle steels with higher yield strengths, as much as twice that of a structural steel.
Look, up in the sky, it's a bird!
It's a plane!
I wonder how ductile the Man of Steel is. Engineering Marvels is a joint production of the Frank H. White College of Engineering at Texas A&M University Kingsville and South Texas Public Radio. Past episodes are available online at tamuk.edu/engineering. I'm Jason Martin.